Hey everybody, welcome to Pre-Calc Unit 2 Review, Equations and Inequalities. In this video, I'm going to work out the solutions to the hard copy of the Unit 2 review I gave out. So the first section here is going to be calculator and active. Question number 1 is a fractional equation. One thing you want to remember to do with this fractional equation is to multiply each term by the LCD. Now I want you to write it out. So as we look here, I've got a 3x, a 12x, and a 6. LCD of those is going to be 12x. I'm going to multiply each term by 12x. Now the reason we do that is because I want the denominators to cancel. It's an equation, so I can multiply through by whatever number I want. And in doing so, check out what happens. X's cancel here, 3 goes into 12 4 times. I'm going to distribute that 4. That gives me 4x minus 8. In the second term, 12x cancels 12x, so I'm just left with the 2. And then my term on the other side equals, 6 goes into 12 twice. I've got 5 times 2x, that's just 10x. So by doing that, this equation is so much easier. I'll subtract 4x over. That's going to give me a 6x here. Combine those two, that's negative 6. Divide through by 6, and x equals negative 1. All right, the next one. I've got a cubic. I wish I could take out a GCF, but notice there's no x over here. I can divide them all by 2, so that's going to make this problem a little bit easier. Notice 2 goes into every one of these. So the first thing I'm going to do, let's divide that off. It's not going to affect your roots at all. That gives me x cubed plus 5x squared minus 9x minus 45 equals 0. Now it's going to be a factor by grouping. I'm going to group these two terms together, and then I'm going to group these two terms together. All right, take out a GCF of x squared here, and I'm left with x plus 5. Now, we talked about this in class. In order for this to work, my other factor over here has to be an x plus 5. So you can almost put that in right now to determine what you need to factor out. So if I make this an x plus 5, I ask myself, what did I have to factor out of these to give me an x plus 5? And I think it's pretty obvious you took out a negative 9. So I factored GCF once, twice. Now I need to do it a third time with these two. X plus 5 will come out front. And then what I'm left with is simply going to be x squared minus 9. That's going to go in here. Then we can factor x squared minus 9, so I get x plus 5 times x minus 3, x plus 3, all of that equals 0. And now we can quickly do our roots. Negative 5, comma, plus or minus 3. Or you can list them out separately. All right, next one's going to be fun. X squared minus 4x plus 29 equals 0. Right away, I can tell that's not going to factor. 29 is a prime number, so the only factors are 1 and 29. There's no way you're going to get a 4 by adding or subtracting those. So you have two options. Number 1 is a quadratic formula. But this is also a good candidate for completing the square, right? This is a 1, and that's even. So I'm going to complete the squares. I like that process. I think it's a little quicker. X squared minus 4x, you have to subtract the 29 to the other side. So remember how it works. I take this, you divide it by 2, and you square it, and that's what you can add here and here. All right, half of negative 4 is negative 2, squared is 4, so it's going to be plus 4 on both sides. And again, I'm not going to show all of this, but what's nice about completing the square is you end up with two identical factors, which you write like so. That's going to give me x minus 2 squared equals, and that's negative 25. Now I take the square root of both sides. X minus 2, remember when you're solving an equation with a square root, you get plus or minus. The square root of negative 25 is 5i. Then I simply have to add 2 to both sides. I get x equals 2 plus or minus 5i. So even though it doesn't say a plus bi form, that's as simple as we can get it. You can expect to see some negatives under radicals. Now, those are 3 equations. We're moving on now to inequalities. Solve each of the following inequalities analytically. Give a complete solution showing all work. When it comes to absolute value inequalities, always write it as two inequalities. The first inequality is going to be exactly what you see there without the absolute value. So 6 minus 2x is less than or equal to 4x. And the other one's going to be 6 minus 2x. Now we flip the inequality, so greater than or equal to, and we negate what's on the other side. Okay, so now what I need to do is solve each one. I'm going to add 2x to both sides. That gives me 6 is less than or equal to 6x. Divide both sides by 6. 1 is less than or equal to x. I'm not a big fan of having the x on the right side of an inequality, so I'm going to flip it around. Okay, over on the other side, I'm going to add 4x. 6 plus 2x is greater than or equal to 0. This is just going to avoid dividing by negative. Subtract 6 over, so 2x is greater than or equal to negative 6. Divide by 2, x is greater than or equal to negative 3. Now comes your number line. Negative 3 is the smaller number, goes on the left. 1 is the bigger number, goes on the right. X is greater than or equal to 1, closed circle shaded to the right. X is greater than or equal to negative 3, closed circle also shaded to the right. So what do we do when we have both inequalities going the same direction? Well, one of these most likely is an extraneous root, so I need to reject one or the other. Usually when we have an absolute value equation or inequality, I'm a little suspect of a negative, and here's why. No matter what you plug into this expression, you are then going to take the absolute value. So this side is going to be positive. Well, if I plug in a negative over here, that's going to give me a negative. So I end up with a positive being less than a negative, and that's impossible. So I'm going to reject this one, which rejects that part of the inequality, and my solution is just going to be x is greater than or equal to 1. Okay, moving on. Example 5. Again, an algebraic solution. The first thing I want to do is move the terms on the right over to the left. This is going to give me 3x squared. 10x plus 2x is going to be plus 12x. Subtract 6, and that's going to give me plus 9. It's less than 0. Now, once again, if you notice, there is a GCF. I can divide 3. So I'm going to divide both sides of the equation by 3. And I get x squared plus 4x plus 3 is less than 0, which is a lot easier to factor. X plus 3, x plus 1 is less than 0. So I get these two values, negative 3 and a negative 1. Now remember, any inequality means I have to do a number line. All right, so let's do a number line over here. I've got negative 3, that's a smaller number, and negative 1. Well, there's a pattern for our plus minuses. If you notice, this is a positive quadratic. So it's going to look like this. This piece is plus, that piece is minus, that piece is plus. Above, below, above. So I can throw those in right now. I don't actually have to test numbers because I recognize that pattern. Positive, negative, positive. And we have to interpret the inequality. Notice what this says. Less than 0. So it wants the negative pieces, and I have open circles. Open circle, highlight the negative piece or pieces. Now I just have to express that. Negative 3 is less than x is less than negative 1. All right, probably the most challenging one here is a rational inequality. And there's those 6 steps that we went through in day 5. So the first thing we're going to do is set it to 0. So I get 5x over 2x plus 3 minus 4 is greater than or equal to 0. Next, I need to get a common denominator. Well, I'm going to multiply this by 2x plus 3 over 2x plus 3. And when I do that, this stays the same, obviously. 5x over 2x plus 3 minus, let's distribute. 4 times 2x is 8x. 4 times 3 is 12. And that's over 2x plus 3. And all of that's got to be greater than or equal to 0. Here's the trick to this one. You're subtracting this whole group. So we have to distribute this negative. 8x is negative, and then the 12 becomes negative. So now when you combine, you have 5x minus 8x, which is negative 3x, minus 12 over 2x plus 3 is greater than or equal to 0. And that is what we're going to be using for the rest of this problem. Okay? So now, once you get it to be a single fraction, you need to find roots. How do you find roots? You set the numerator equal to 0. And I'll just go through that quickly. Negative 3x equals 12. X equals negative 4. So that's going to be my only root. Next, I find the restrictions. Well, how do you do that? You set the denominator equal to 0. 2x plus 3 equals 0. 2x equals negative 3. X equals negative 3 halves. So I found my roots. I found my restrictions. Next comes the number line. Negative 4 is the smaller number, goes on the left. Negative 3 halves would go on the right. And remember what we do here. I plug in random numbers. So negative 10 is less than negative 4. I'll pick a negative 3, and then over here I can pick a 0. So rather than try to evaluate this whole expression here with a negative 10, I'm going to treat the numerator and the denominator separately and then just ask myself, okay, well, if I have a positive divided by a negative, overall that's going to be negative. If I have the signs that are the same, overall that's going to be positive. So let's go ahead and do that. If I plug in a negative 10 here, this gives me positive 30 because it's a negative times a negative. 30 minus 12 is a positive, so the numerator would be positive. If I plug in a negative 10 down here, I get negative 20 plus 3. That's going to be a negative. So the bottom of the fraction is a negative. So now I have a fraction where the top number is positive, the bottom number is negative. So overall, that's going to give me a negative. And that's how we go ahead and do that. Next, I take a negative 3, plug it in here. Well, that means this is going to give me a positive 9. Positive 9 minus 12 is a negative number. So the top of the fraction is going to be negative. I take a negative 3, plug it in down here. That's going to give me negative 6 plus 3. That's also a negative. So the bottom of the fraction is negative. Well, negative divided by negative gives you a positive, so that piece of the number line is positive. And 0 is super easy, because watch this. If I put a 0 in here and a 0 in here, both of these are zeros. So basically, you just cancel this stuff out. What are we left with? Negative 12 divided by 3, which is going to be negative. Now, lastly, what do? We interpret the inequality. Since this says greater than 0, I want the positive pieces. So basically, that's going to be this middle right here. But what about the circles? This is where it gets a little confusing. If that's an or equal to, that tells me my root or roots are closed. Okay, well, my root, if you remember, was negative 4. That's why it's important to know the difference between roots and restrictions. So that's going to have a closed circle. But the thing to remember here is that our restriction is always an open circle because it represents an asymptote. So this is going to be an open circle. Even though this says or equal to, remember you can't be equal to the asymptote or the restriction. So now I just have to write that inequality. That's going to be negative 4 is less than or equal to x is less than negative 3 halves. In question 7, we're going to solve the following system algebraically. What I notice here is that top equation is already solved for y. And what I'm going to do is I'm going to take that stuff and I'm going to plug it into the y in the other equation. And when I rewrite it, don't think of the y as a y, think of it as input. So I have input minus x plus 1 equals 0. And that's this equation right here. Now what I'm going to do is substitute this expression in for the y. So that's negative x squared plus 4x minus 1. Let's combine like terms. Negative x squared. 4x minus x is a positive 3x. Negative 1 plus 1 cancels, and that equals 0. So now I can just factor this. Take out a negative x. So that gives me x, and be careful, minus 3 equals 0. And I get two roots. X equals 0, and x equals positive 3. Now, we're not done. We just found both x coordinates. We need to find the y coordinates now. You can plug into this. That wouldn't be an issue, plugging in 2 spots here and here. It's really not that bad, but it might serve us well just to solve the second one for y. Just going to make it a little bit quicker. So this would be y equals, add x to both sides, subtract 1, y equals x minus 1. So y equals x minus 1, that's going to be -1. Y equals x minus 1, that's going to be 2. And I would prefer if you write these as ordered pairs. Again, it just reinforces you're finding 2 points of intersection. So that's 0, -1, and 3, 2. That would be your solution. All right, let's move on to the calculator active portion. Now, I would prefer it here if when you do these with your calculator, you set them to 0 first. It's just going to make it a little bit easier, and it's going to make it more consistent for us for the rest of the year and for you guys moving forward into calculus, because we just know we have to find all the roots every time. In question 8 then, I'll subtract 3x over. So I get 2x squared, 5x minus 3x is 2x. And I'll add 4, so that's -5, and that's greater than 0. It's the only algebra you need to do. Now indicate you're going to put this into y1, and you're going to sketch that graph. All right, I'll do that over here. It's going to be a little bit small. So here's my sketch of y1. Now, what you need to do, all right, again, I wish I could show you guys this on the calculator, but I would recommend putting in a y2 equals 0 and using your second calc intersect to find these roots. Don't just trust that they are integers, because they're not in this case. And I'm going to round to the nearest, I'll just do 10th. So for this first one here, I got -2.2 comma 0. And then this one here, I got 1.2 comma 0. Now, what we do next is we interpret the inequality. Greater than 0 means above the x-axis. Well, what part of this graph is above the x-axis? Open circle, that piece is above. Open circle, and that piece is above. So what I'd like you to do now is represent that on a number line underneath. This value is going to be -2.2, and this value here is going to be 1.2. And what do we have? We have open circles, and we're shading the tails. How do you write that as an inequality? Well, it's pretty simple. You do x is less than -2.2 or x is greater than 1.2. Okay, number 9. Again, let's set it to 0. It just makes it that much easier. Absolute value x minus 3 minus 2x is less than or equal to 0. I'm going to put this into y1. Just make sure the minus 2x is outside of the absolute value, so you have to arrow over to put it outside. This graph is actually pretty simple. It looks strange because we're used to seeing a v for absolute value, but this changes one of the arms, if you will, of that graph. So I get something that kind of looks like this, and then the vertex is there, but it bends that way. Well, it's pretty obvious to me this is never going to come back down and hit the x-axis. It's obvious to me that's never going to go back up and hit the x-axis, so I only need to find that one point right there. Again, I would do second calc intersect. That one works out very well. That's 1, 0. Now let's interpret the inequality. What does this want? Less than 0 means below or on x-axis. So this is going to be a closed circle, and I want the piece that's below. And all I need to do now is put that on a number line. There's only one value, it's 1. It's a closed circle, and I'm shading to the right. So the solution here is simply x is greater than or equal to 1. All right, we finally made it to our, almost our last one. Question 10, rational inequality graphically. Set it to 0. X plus 4 over x minus 3 is greater than or equal to 0. And put this into y1. I don't want to do any algebra. Don't combine them into a single fraction. All right, that's only for an algebraic solution. Okay, so if I do that, my sketch kind of looks like this. couple things I want you guys to note. Looks like that's an asymptote right there. I need to find this point of intersection right there. So I'd have a y2 equals 0, second calc intersect. Let's find that. And for that one, I got 1.1. So again, don't trust that it's an integer. 1.1 comma 0 is that coordinate. Now let's interpret the inequality. This says greater than or equal to 0. So again, that means above or on the x-axis. Well, that means that point and this piece. None of this is above or on, and none of that's above. So how do I get this to be, erase that, number line? Okay, well, there's actually two values I have to put on my number line. One of them is 1.1. The other one is my asymptote right here. That's a 0. And what do I want? I want a shade in between. So that's going to be a closed circle. I shade this way. Asymptote's always open. So my inequality is going to be 0 is less than 0 is less than x is less than or equal to 1.1. Okay, and the last one, finally. I don't know why we gave you guys a grid here. I don't want you using that. All right, when you solve graphically with a calculator, we're just going to have a sketch, not on a grid. This equation is already solved for y. So if you want, you can put like a little y1 here. The bottom we just have to add 3x. So maybe y2 equals 3x plus 5. You're going to put both of these into your calculator. All right, and you're going to show us a sketch. Do that over here. And I'll show you what I did for my window. So it looks like I have something sort of like that. That's going to be your y1, the cubic, obviously. And the line kind of comes through like this. All right, so there's your y2. So what I need to do is I need to find these points. 1, 2, 3. And I don't have room to write them there, so I'm going to label them P1, P2, and P3 and use second calc intersect. P1. And notice this one does say it's round to 1,000th. That's 3 decimal places. All right, so P1, I got negative 4.860, negative 9.579. P2, I got negative 0.574, comma, what is that, 3.278. And P3, I got 1.434 and 9.301. This finally concludes the end of the video review. If you have any questions, don't hesitate to reach out. Thanks for watching, and good luck on the exam.